In this section, I'll introduce you to the basics of modern portfolio theory and the capital asset pricing model. In this video, I'll review basic statistical concepts. Then, in class, we'll discuss how you diversify a portfolio and why you should diversify your portfolio. Then, we'll introduce modern portfolio theory and discuss how you optimize your portfolio based on expected returns, standard deviations, and correlations between random variables. Finally, we'll talk about how we predict stock returns, and we'll introduce the concepts of beta and the capital asset pricing model. Now let's start our statistics review by discussing covariance. Covariance measures the degree to which two assets move together. The higher the covariance, the more positively that two random variables move together. If covariance of two random variables equals 0, then we say that the random variables are independent of one another and their stock returns will not be related to each other. Negative covariance indicates that high values of one random variable are likely to occur when there are low values of the other random variable. Next, we have correlation. Correlation can be considered scaled covariance. It represents how random variables move with respect to one another. Correlation ranges from -1 to +1, with +1 indicating that the two random variables are perfectly positively correlated with one another, while -1 indicates that the two random variables are perfectly negatively correlated with one another. Correlation coefficients of 0 indicate independence between the two random variables. If we know the covariance between two random variables, we can divide this number, this covariance, by the standard deviations of the two random variables to calculate our correlation coefficient. So let's take a look at what positive and negative correlation looks like. Positive correlation indicates two series tend to move together in the same direction. Negative correlation indicates that two series are likely to move in opposite directions from one another. Notice here that we have two random variables that are perfectly positively correlated in the bottom left-hand corner of our screen. This perfect positive correlation indicates that a rise in random variable p will always have a comparable rise in the value of random variable m. With perfectly negatively correlated random variables, like those that we have in the bottom right-hand corner of our screen, an increase in n will always have a corresponding decrease in m. Perfectly negatively correlated random variables are something that we're always on the lookout for, since we can use the negative correlation to achieve a guaranteed return with no risk, which we'll talk about in class. Now, there are some final points you should know about covariance and correlation. First, the covariance of any random variable with itself is simply the variance of that random variable. Also, the correlation of a random variable with itself is equal to 1, indicating perfectly positive correlation. Finally, the variance of the quantity of a random variable plus another random variable is equal to the variance of random variable 1 plus the variance of random variable 2 plus 2 times the covariance between the two random variables. We'll use this formula when we want to calculate the variance of an entire portfolio. We'll modify it to some extent, however. Now, let's calculate the correlation and covariance of two stocks' returns in Excel. So I have here an example. We have two securities, Security 1 and Security 2, and we have some basic information about these two securities. So let's use Excel to calculate the covariance and the correlation between these two random variables. So let's start with the covariance. Now, our covariance formula in Excel is going to be covariance.s. So equals covariance.s, and this indicates that we're using the sample covariance, since we only have a sample of the stock returns of these two securities. So what we're going to do is we're going to highlight the returns of stock 1, put a comma, and then highlight the returns of stock 2. Close our parentheses, hit enter, and our covariance between security 1 and security 2 is 0.00235. Now, our correlation coefficient is going to be simply calculated using the Correl function. So equals CORREL. And again, we just highlight the two arrays or two series of data points that we want to use. So in this case, I will highlight array 1, or the returns of stock 1 over these years. And then I will put a comma and then highlight our returns for stock 2, close our parentheses, and now we have our correlation coefficient. Now, what this correlation coefficient of 0.11036 indicates is that we have some positive correlation between these two random variables. In other words, when we see high values for the returns of security 1, it's likely that security 2 is also going to have higher values. So in other words, the returns of these two stocks are positively correlated with one another. Now, the reason I'm reminding you of how to calculate correlation and covariance is because we'll use these formulas to optimize a portfolio using what's called the modern portfolio theory. But let's talk about the difference between the traditional investing approach and the modern portfolio theory approach. With the traditional investing approach, or the traditional approach to portfolio management, the goal is to identify securities that allow you to create a balanced portfolio across industries. While you're still diversifying your portfolio, you might overweight securities that are well known, like stocks of firms listed on the New York Stock Exchange. You might also invest in stocks you believe are less risky. The big difference between this traditional approach, or this traditional investment strategy, and that of the modern portfolio theory that we're going to be talking about in class is that you're not directly optimizing the Sharpe ratio of your portfolio when you use the traditional approach to investing. The modern portfolio theory essentially requires you to use three components: expected stock returns, stock volatility, and the correlations between each random variable or each stock's returns, and it allows you to optimize the weights of the various stocks in your portfolio. And when you do this, what you're doing is you're maximizing your Sharpe ratio. Now, here's an example of a portfolio that was developed likely using the traditional approach to investing. This Growth Fund of America that you see here is a mutual fund that holds securities across 10 of the 11 sectors of the U.S. economy. This fund's management chooses to underweight and overweight various sectors in their portfolio relative to their benchmark. So with basic materials sector, you can see that they've overweighted this sector relative to their benchmark. With the tech sector, you can see that at the time I pulled this data, this mutual fund actually underweighted the tech sector relative to their benchmark. The management of this fund will typically determine which securities to hold and which sectors to overweight or underweight based on something called security analysis, which we're going to be discussing in a couple of weeks. Now, what we're going to do in class is learn how to use modern portfolio theory to maximize the Sharpe ratio of our portfolio based on expected stock returns, stock volatility, and the correlations or covariance between those stocks. And that's it. What you'll see is that if you can identify those three statistics, you can identify the optimal weights of the various securities in your portfolio. And with that, I'll wrap up. Now, if you have any questions about covariance, correlation, or the calculations I showed in this video, please don't hesitate to reach out to me via email or in class. But if you don't have any questions, I suppose I will simply see you in class. So, thank you very much.